Hello, fellow. My name is James Owusu-Appiah, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
Uh-huh. So the labeling, that's what I kind of label all of them. So this is the data memory register, the data memory output enable, as you can see. So this signal, that's the name of it. This is the instruction memory output enable, right? Uh-huh. So take note of all these this thing. This register the input enable, and the same thing apply for all the other components, right? So once I've kind of been able to group all the wires, and one thing you should note is that, so if as you add more additional components, the wiring become more messy and then more complex or something like that. But it take getting used to it to be able to kind of organize your work and then be able to do it. So basically, if you know how to use the software, right? So I mean, if you know how to use the software, it become very easy to kind of expand and then make changes as the need arises. Uh-huh. And even for instance, why I say you could kind of take them up or something like that. So just get used to work what you see. So and these are the things that actually make the microprocessor design or stuff look kind of complicated or confusing, because I mean, see how the diagram is like. Uh-huh. So but that just to focus on what is here. You just still need to focus on what the important things here, the components, and then you know that these wires, they are all control signals that you can use to control this signals. I mean, these components, right? Uh-huh. So kind of try to understand them, right? Uh-huh. So let's take this one for instance, the data memory I just registered. So you see, I didn't really explain that, but for a register, once the enable pin is high, or at that time it listens to the clock. But then when the enable pin is low, it does not listen to the clock, right? Uh-huh. So even though they are all right and it's triggered, if the enable pin of this thing is low, it's not going to listen to anything in the clock. Whether the clock is rising or falling, it will not listen to anything of that kind, because the enable is low, right? And this is important, right? Because as you can see, all of them, their input are connected to the data line. Well, we don't want them to be reading all the time, so that's why you have to take the control signal, and we only enable them, when we want them to read. Not all the time they should be reading from the data bus also. We don't want them to be reading all the time, right? So that's why we have to control when they do all these things. And as you can see, we connected all their clock together, so they are all synchronized. So we have control over when they all do things. So with that, I will just try and bundle all these wires together and then bring it back. So I'll get the wires later. I'm just trying to get a bundle, so nothing so much. So how many? 1, 2, 3, 4, 5, 6, 7, 8. So about 8 wires, and so this also 8. So I will just connect all together like that. So this is just a wire splitter. There's nothing, even though it's the logic, you will know how to go about this. So the purpose of using a wire splitter is very simple. Like, I want to kind of bring everything. So instead of bringing all these plenty of wires here, like, just bundle them together and then just bring one of it here and make it easier. So I'll do the same thing for this one too. 1, 2, 3, 4. I'm also going to bundle it together and then get to bring it so that it can be fine. So this 4, I have about 1, 2, 3, 4. So that is 4, yeah, that's 4 lines or 4 wires there. So let me do something about that. Yeah, let me do something about it. So let's see what I can do. So let's connecting the components. Let me readjust the bit size of it. Which have 4 fan out, because there are 4 components. And then I'm going to make it set the bit width into 4 bits. Okay, and that's all. So once I have done this, I can put it together here, and now all I have to do is to kind of get to, so once I bring them I would like to kind of split them apart again. So when you have, just always take note of, yeah, so you can kind of check on how to do this thing on logistics. Just go to the tutorial, the help tutorial, and then you see all how everything like this can be done. So let's see, I'm going to get a, so I also get another wire splitter. So one have come here, I have to split in apart again to be able to access. In the same way too, I'm going to kind of, you can see where this is 4-bit bundle. This is a 4-bit bundle, and this is another 3-bit bundle, and then this is also another 3. So this is 3-bit, 3-bit, and 4-bit. So I want to split all the wires apart and then be able to access them. Yeah, so that's what I'm going to do right now. Yeah, so as you can see, I'm just kind of, splitting this bundle together to access each bit, to be able to access each bit by bit. That's what I'm doing. Now, in the same case too, I'm going to also split that bundle. So let me just copy and paste that wire and bring this one here. So this is quite easy to follow once you know what you are doing. Next time, I would like to keep then alright, so now basically let's see what we have here. Let's see what we have here. So I'm kind of trying to group all the this thing. I'm just rearranging them. Not too much. Yeah, so I have just kind of rearranged the wires better. Just by grouping them, and the aim of this is so that you can be able to kind of understand what is happening. And as you can see, I think all the arrangement of the components have been done, and we have our basic microprocessor template. So this is a basic template that we have here, because all microprocessor will need a program counter, it will need an accumulator, it will need an instruction or current instruction register, it will need a micro instruction counter, and then it will also need some kind of feedback. I mean, additional input from the system apart from the rest. And then, okay, so let me rename this. It's actually micro instruction counter. Let me write it MIC. Okay, so okay, so these are going to be yeah, these are the various components. So that's why I say it's a basic template, right? So after this and depending on other instruction that you'll be executing, you might need, so maybe you want to have an add instruction or subtract. All these instructions will require that you have an A or U, right? So your logical operation of those things can be there. And but I just want to, with this design, we will kind of implement the control unit in the next section, right? Then you see how we are able to design a control unit to be able to move data around. So we could move data from the accumulator into the data memory, or move something from the instruction memory to maybe the accumulator, and we also move the content of the program counter to this instruction memory address register. I mean, so the next thing we'll do will be implementing the control unit, and then we will kind of implement some of the free instructions that we plan of executing. Yeah, like some basic instructions, and then mostly this instruction will basically be moving data around. Yeah, like that's how it's like. So this is one of the difficult tasks. I mean, kind of creating a schematic. I mean, arranging the components, connecting them. It takes time getting used to. So now what we have here, look at this thing that we have here, right? Basically, a control unit. I'll talk more about a control unit in the next part. But as you can see here, this space that we leave here is actually where our control unit is going to sit, right? So as it sits here, is going to receive it will get input. So this will be the input from the system, right? So this they are all overall, they are all feedback or things that these are the input they get from the system, right? So on seeing this input, the control unit will now output signals to say, oh, what should be done next. So that's why I see these control signals, they are the output, right? Because that's what it will be commanding to do the next of actions, things that should be done. That's what it will be commanding or something like that, as you can see. So these are the inputs. This is what it sees, and then seeing these things, which represent the internal parameters of the system, it now decide what should be done. So this is where the decision making come into play. This is the control unit. This is where it will sit. As in the next session, we'll design a control unit. So yeah, I think that will be all for this part. I mean, I'm sure there are other things that you want to understand, so you can try to kind of research on it, do some Google search or some YouTube search, and hopefully you might find some things that you'll be able to understand some of these things. And then so the same thing also, yeah, you can search on those things that you don't understand. Or maybe if you meet me in person too, yeah, you could also kind of ask me some of your questions, and then I'll try to clear them out for you. So for now, this is our data path design, right? And we have been able to arrange the various components that we think we need now. So later on, if you need additional components, you have to put them on board and then try to connect them also. The same connection follow. You have to get a control sickness to come to a control unit. And then, yeah, for this part of the design, it will be fixed, I'm sure. Yeah, because of now, for this part, it's going to be fixed. I don't think we'll need any other additional input to the control unit. This input will be fine for what we'll be designing. So that's it for now, right? And there's one thing. So you see this one here, right? I didn't show you how I kind of came about that. I made a change maybe during one of the pause period of the video. So if you see here, this one, right? Normally most registers RAM or data, RAM, they have the tri-state buffer feature of them. So what that means is that they can disable their output totally. Like they can disconnect their output from the data line. And so they can disconnect the output from the data line. So in that case, they don't need a tri-state buffer to do that, to achieve that, effect. But I just for uniformity, right? I chose just to use a tri-state buffer for all of them to make it easier, like have a uniform interface. So that's why what I did here was that I kind of I make to always load the output of to always load the content, right, always to the output. So what it means is whatever the output is always connected. That's what I did. Because we already have a tri-state buffer to control that thing here. So by setting this on to high, it ensures that whatever is here, whatever is stored at the current address will always be visible to the output. So that's why I tied this one to a 1, to a high. The rest of the things I just like that. So if there's any other clarity, maybe all of it will be seen in the next video, in the part 3. So okay, thanks for watching, and I hope you learn a lot, and I hope you will be able to follow it and then do your design. All right, see you in the next video.